smarter if you, unless you're calculating only GU, in which case it doesn't matter. But if you're calculating GU and GDIs, calculate the C transpose times that first. Okay? So, next thing I'm going to calculate is C transpose SI minus A. So my C transpose is what? 4, 0. And you could have put that denominator in every element here, but I'm saying don't do it. It actually is best if you leave it in that form until the very end. So 1 over s squared plus 3s plus 5 times s plus 2 minus 1, 3, s plus 1. This is a scalar. Remember, scalar can be freely ferried to the right or left. Let's move it to the left. And then I have this row vector times this matrix. 1 by 2, 2 by 2. What's the result?
1 by 2.
1 by 2. So that's going to be the scalar. And then I have this times that. Remember how you multiply that? You take each row with corresponding columns. So the result of this multiplication is going to be 4 times s plus 2 plus 0 times 3. So that's 4 s plus 2. And then I have 0 times minus 1, 4 times minus 1 plus 0 times s plus 1. So that gives me minus 1. So that's C transpose SI minus A inverse. What do I need to calculate next? That times B. So C transpose SI minus A inverse times B is going to be the B vector is what? What multiplies U primes? The 1, 2. Okay? Yeah. This is the B. Okay. This is the C transpose. This was gamma 1. This is gamma 2. This of course A. Okay? Pretty clear. So, that times B, I'm multiplying this by 2, 1, 2. So that's going to be, and you can now, okay, 1 over s squared plus 3s plus 5. And you have this times this plus this times this. So times 4. Now that's a scalar. 1 by 2 times 2 by 1. 1 by 1 scalar. So 4 times s plus 2 minus 4 times 2.
Yeah. Okay.
Okay? 4s plus 2 times 1 minus 4. So that gives me 4s. And here I have 8 minus 8. Oh, interesting. Okay, 4s only. Unless I messed up the algebra, 4s. And denominator s squared plus 3s plus 5. Interesting. Not the best number I want if I want to use this example for other things, but it's fine for this. And GD of S, we're ready now to calculate that, is C transpose SI minus A inverse B e to the minus ds. What's my d here? 7, right? It's whatever is here. So it's going to be simply 4s over s squared plus 3s plus 5 e to the minus 7. That's my transfer function. Notice that the denominator is a quadratic polynomial. It will always be a polynomial of degree n, where n is the size of our A matrix. So I have 2 by 2, it's going to be a second degree polynomial. I'm saying this approach is not practical, even if we have the linearization, even if we have a symbolic manipulator to calculate a sine minus A inverse. Because if I had the distillation column in the lab that has 96 state variables, that would be a 96th order polynomial. Okay? That's what we would have then. A 96th order polynomial. But it's good for easy example. Okay. What about GD1 of S? GD1 of S is C transpose Si minus A inverse gamma. Sorry, GD2 of S. Sorry. I need GD2 of S. I asked for GD2 times gamma 2 e to the minus. I already have calculated this guy. C transpose Si. I already calculated that. So that's going to be 1 over S squared plus 3S plus 5 times 4S plus 2 minus 4 times gamma 2. What's the gamma 2? 2, 0, right? So times 2, 0 times e to the minus ds, so times e to the minus 7s. I'm doing it a little bit more directly here. So that's going to be 1 by 2, 2 by 1, 1 by 1. So that's going to be 4s plus 2 times 2 minus 4 times 0 over S squared plus 3S plus 5 e to the minus 7s, or you can write it 4S, and here I have plus, okay, oh, sorry, 8S. 8S plus 8 times 2, 16 minus 4 plus 12 over S squared plus 3S plus 5 e to the minus 7. So that's GD2 of S.
Dr. Swartz,
Yes.
it's minus 4 times 0, so wouldn't it just be 16?
Oh, yes. Thank you. 4 for 4 me. Okay? Yes. Okay. So we see how I get the transfer function now? But this is, so any questions before I move next? This is for the model in which we have no delay, no derivative in the measurement equation, which is a very common situation. But sometimes you want to consider dynamics in the measurement equation itself. So a more general model sometimes you need to consider dynamics in the measurement equation. example is to have something like a parameter So instead of having this, you just have a term that has the first derivative of y prime.
What is the symbol from? Tau sub m?
Tau sub n. It has the units of time, so associated with the measurement, so tau sub n. I just put some symbol.
Okay, so it's some measured time.
It's a constant, it's a parameter. Okay, so suppose the measurement model is like that. What can you do in that case? You can't, these formulas don't apply. Then, let's put some symbols here. Let's call this triple star. Then triple star cannot be used. Okay? What can you do in that case? Well, I would again Laplace transform this expression. Now the result is going to be a little bit different than before. So let's call this double star or star B alternative. Since I had called this star A, star B, let's call this star B alternative. You lost me. Okay. Let me go. Someone help me out with the question where you lost me. Where did you lose me? Angelica, you lost me. Where did you lose me? No? Okay. I mean, this class, guys, has totally different concepts from any other class you have had. No question about that. It's more like an applied math class. But so, okay.
Okay, so what is the equation, like what is your tau y, what is that equation for?
Instead of having this measurement equation which we treated until now,
Right.
suppose we have also a differential, the derivative of the measurement involved. This gives some dynamics to the measuring device itself. It can happen in some cases. Okay? Usually, tau m is so small that you can neglect it, so that's a good model. Okay? But in some cases, it's not so small, so you're better off including it. So let's say I'm giving you this measurement equation, and I'm asking you to find transfer functions as I'm doing in problem 3 of your homework. Okay? How will you do that? You just use the dictionary on this. So let's use the dictionary on this. What do we get? So L, I erased whatever before, but L star B all follows. Left hand side of this, tau m is just a number, factors out. What do I do with y prime dot?
What do you mean by PSR cannot be used?
Well, those two, these expressions, we derived from using this measurement equation.
So why are you going to come up with that?
Because sometimes you cannot just use the Kant equation. Okay? You can't always use the Kant things. You need to have the understanding to be able to use what needs to be done.
So basically, we're just deriving another equation for this situation.
I'm not going to do a whole thing. I'm just going to give what we do with this equation. And if I have enough time, I might do something like your homework with different numbers. Okay, default. So what do I do with y prime dot? The box, exactly. That's going to be S y prime bar minus y prime of 0. What about that y prime of 0? What do I do with it?
Cancel.
Kill it. Implied assumption. Every deviation at time 0, 0, that's implied assumption. Okay? And then I have Laplacian of this is what? Y prime bar. And this we just saw before. Just like before, C transpose with implied assumption, x prime bar bar e to the minus ds. So now you get that tau m times s plus 1 from here, y prime bar, a plus C transpose x prime bar bar e to the minus ds. And just plug in x prime bar bar and proceed. So y prime bar is going to be 1 over tau m s plus 1, okay, times C transpose x prime bar bar e to the minus ds. Plug in for that, and you'll get it. Clear? Someone read to me homework problem number 3. Actually, let me quickly put it in. I have 10 minutes. That should be enough. That should be good. Okay, let me quickly do on this screen, right? So.
So homework's due next
Huh?
week. Homework's due next Thursday,
Yeah, homework is due next Wednesday.
Wednesday.
Yeah, homework 3, with this I have covered everything you need to do for homework 3. So it's due next Wednesday. Yeah, definitely don't want to make it due Friday since some of you have an exam on Friday.
We don't have class on Friday.
Huh?
We don't have class on Friday. This class. We don't have on Friday. Monday, Wednesday.
This class is only Monday, Wednesday, so it's 50.
Yeah, okay, that's right. Yeah, no, we don't have this. But, yeah, you're right. So you're starting your holidays.
Next Friday.
Alright, so if we go
Yeah, next Friday.
to your homework,
Just said.
so if you look at homework number 3, I should be able to do everything.